Okay, the question arises to how to take this hypothesizing the next step, and the loose end now is Nathan Stubblefield. What does that have to do with Tesla's trimetal or special generator? What does it have to contribute? And before or because of, or how it should be answered, would be to ask one more question. What does John Bedini leave us with on his webpage devoted to Stubblefield? He leaves us with an unanswered question which he doesn't answer for us. He poses it as as if it were a general question that nobody knows the answer to yet. What is the third coil for? And I just sloughed it off when I first read the patent a couple of years ago. But he thinks it's a means of priming the thing, and that it's not a battery. You know, when it's called an earth battery, there are two different ways of interpreting that. You can say that the device is the battery, which is simply buried in the earth. But the other way to interpret it is to interpret it literally, that the earth is the battery, and this is merely a device by which the Earth's battery sense can be harvested or utilized. Now, one thing that's not in the patent, at least I'm sure there's several things not in the patent that belong there if we wanted to know all the details to make it operational, since patents don't give us everything, right? Rarely does the inventor put it all there in the patents. So, one of the clues on the storylines, and it might be another page of John Bedini's that gives us the clue, that it's buried. He had the habit of, he told a friend, off the cuff, off the record, that he preferred to bury his earth batteries among the roots of an old oak tree, wait a year, and it would get up and running. Well, I'm thinking, okay, roots of a plant put out acids, they break down rocky matter, so maybe it's doing something to oxidize the iron windings that are not protected, and so they create an iron oxide coating. It becomes like a diode, and the copper is protected because it's sleeved with cotton sleeves that are actually coated in a resinous material insulator that Tesla liked to use. Could be beeswax, could be pine rosin beeswax and carnauba wax, whatever. All that's very well and good, but the trigger coil, this other third coil, because Bedini said it kind of looks, what did he say it was, a rectifier or a transformer? A DC transformer or a rectifier? Now I'm getting my stories mixed up. Anywho, yeah, I think he did say it. Well, let's put that aside. The trigger coils. So I have to ask myself, okay, what's the trigger coil connected to? Is it connected to an outside power source? Well, what did Bedini do with trigger coils? When he had a trifilar coil, that third coil, the trigger coil, or the third wire wrapping in the composite of trifilar winding on his little schoolgirl motor, it definitely was a trigger coil. So what do we hook it up to? A tree. In the same time frame, we have, more or less, give or take a few decades, we have George O. Squier, General Squier, who was, I think, in the U.S. Army, but he might have moved from the British, because he had his first patents, I think, in Britain, and then he had issued patents to him in the United States for making trees into radio antennas for field operators, for the Army radio operators. And he does a whole thing about how to use trees as antenna, far superior to the antenna that comes with the field radio. So I did some experiments with trees, and I even connected my consciousness to a tree. I was managed to do, and they're very interesting consciousness, very I don't want to say anything more. You might think I'm nuts. Actually, I had a tree, yes. Okay, we won't go there. It's not germane to the topic. Okay, it's just sidebar. So what if the tree, because it does act as a grounded antenna, act as a trigger coil. So we take George O. Squire's patent idea, which is to run a wire from an iron nail hammered into a tree. He found it to be advantageous 2/3 up the trunk of the tree, but regardless, as high as your hand can reach. And it must be iron. I mean, at least it cannot be copper, let's put it that way, because copper will kill the tree. I don't think aluminum will do it much good, but iron, it's a nutrient, and it grows up around it, so you have to hammer it in deep enough to reach the sap layer, which can then mean that the nail is groundable to the earth through the tree trunk and through the roots. So now and can connect as a radio antenna through the leaves and whatnot. The whole capillary system of the tree becomes one huge antenna in the shape of a fractal, which only Mother Nature could have devised. So I used to do this all the time when I was up in the Cascades, grounding my earthing bedsheet to a tree, a huge conifer tree, 75 yards away from the building, to make sure I reduce the AC interference from the AC house neutral line, grounded line. Of course, in Stubblefield's day, 1876, there were no power companies to deal with. Tesla hadn't set one up yet. So they had no interference in the earth, or in the air for that matter. The only radio interference might come from telegraph wires, but that probably would be minor. So we've got a tree as a trigger, and we've got the earth battery situated among the roots of that tree for a year or more. And what Bedini said on his page was that it may behave like a very weak, wimpy battery at first, which might lend the impression that the device is the battery, but over time should build up an electrostatic charge, I believe was what he was alluding to. But the trigger coil is important. He didn't know how to deal with it. So that's what I think it is. If you're going to plant it in the roots, among the roots of an old oak tree, then Stubblefield must have enjoyed the use of an oak tree as a trigger. So that's my solution to the mysterious trigger coil. I guess there's nothing left to figure out, It's just a question of building one and arranging it according to those two modifications. What to do with the cotton sleeve, soak it in a resinous, waxy compound of some sort to fully insulate the copper winding, wire the copper wire of the portion of the winding with a liquid that is totally derived from plants that we know. We know factually that not just what we've been told, but by our own, we can source it to the source that it came from a plant, whether it was natural shellac or pine rosin, beeswax, carnauba wax combination. But it's not something that we're told came from plants, but we don't know it because we never saw it with our own two eyes, from the source to the retailer. In other words, petroleum does not come from plants. We're told that. We don't know that. That's not an observed fact. That's not an observation. So we work with what we know. We want plant-derived compounds to insulate the copper winding, and then the iron is left bare, which is a little bizarre. But you have to look at the patent. As I recall, I think the layers were like checkerboards, so that the iron wire was surrounded by copper wire on all 5 sides. So if you did a row, a layer upon layer, and then between the layers there was a cotton sheet. Excuse me, a cotton sheet to separate each layer, which again can be shellacked. So you've got no iron wire shorting out any iron wire above or below it, and then you've got copper on either side with its cotton sleeves. So he basically did two things. He created a medium upon which to shellac the copper wire to insulate it, but he also minimized. The power company cuts its wire in half, and so does the telegraph. Back in the second half of the 1800s, they ran the second leg of the telegraph wire through the earth, so they saved them half of their copper cost. Well, what if they're still thinking with that mindset? Nathan has got that mindset, and so he's thinking, okay, I'm going to save on half my insulation because I got to insulate the wire. He doesn't have a company like we have and go out and buy insulated wire. So he says, well, I'll insulate the copper wire for some reason, which poses a mystery why he chose to insulate the copper and not the iron. Maybe because the copper is less disadvantageous to allow it to be subjected to take the risk of subjecting it to the elements. But if you look at the structure of the patent, as I recall, he's got it very highly structured, and so it's quite possible that the iron is fully insulated, even though we don't insulate it. But just because of its arrangement and the liberal use of cotton sheeting and cotton sleeves, sheeting between the layers and sleeves on each cotton along the length of the entire copper wire, that's fully insulated if we take advantage of the fact that cotton is just not cotton. I mean, you're going to immerse this thing in the earth, it's going to get wet. It makes no sense to put cotton. Absolutely no sense unless we soak the cotton in a suitable material that will fully encase the copper wire with an insulating dielectric material. So it's no question in my mind about the cotton material, what it hints at, but doesn't fully tell us. The trigger coil is the other hint that I never solved up until now, and for some reason it becomes very easy. Oh, it's hooked up to the very tree that it's planted underneath. So those are the two clues that are missing from the patent. Otherwise, you just follow the patent. It should be straightforward. Now, as John Bedini was saying, it's pretty wimpy what output this puts out. But did he insulate the wires from each other? No, because he was dealing with a galvanic response in which the iron and the copper was interacting because of the juices, shall we say, the salinity of the soil and the liquid, the moisture of the soil, acting as the electrolyte. But now it's not there to act as the electrolyte. So what's it doing among the roots of the tree? Well, the roots act as extensions of that antenna, the portion that's below the earth. So we've got a loose coupling now between the tree roots and the tree itself and all the coils, but a direct coupling with the trigger coil. So we got two couplings, a direct with a hard coupling, a strong coupling with the trigger coil between the tree and the trigger coil, and a loose coupling between the tree and the two larger coils that actually drive the thing, the iron and copper windings, because they're fully insulated. There's no way to reach them. Now, why should they be a loose coupling and not a strong coupling, see? So we've got a new question that arises that's not obvious. It's not in our face because it's not stated in the patent, but it's implied if we solve the other two riddles. So now we got a third riddle that we didn't have before. Why the difference in coupling? Well, if I had to take a guess, it goes back to Tesla's patent in which he's got the time lag, the time delay between the primary and the secondary based on a metal sheath or membrane between the primary and the secondary based on the width or the thickness of that iron sheathing creates the very divergence that you can vary parameters of construction to vary the time lag between the primary and the secondary, and then play with the phase relation difference between the two. So we've got that now between the two coils, in a sense, but we don't get to play with it because it's pretty much an average fixed amount. But it's going to be there because we've insulated the iron winding from the copper winding of the two main coils. And then we also have a delay between the two coils and the trigger coil. because they're also a loose coupling between those. So there's a loose coupling among all three coils. And that creates a time lag, a time delay, which creates a power factor. So again, we've got a DC transformer because we're going to be having an offset between the magnetic field and the electric field by a slight amount. Slight amount. It's possible that the size of this device might matter or not. I don't know. Actually, there's a reasonable limit, and that would be the spread of the roots. Now, from tree experience, as I recall, you take the drip line of the tree to be the width of the root mass that's underneath the earth. You know, we're forgetting about depth for the moment. So we could have an earth battery reasonably no better in performance if we keep increasing the size of this thing, which is largely or more or less roundish. It's not like a plate, which just has thinness and then breadth. So, or a rod, a grounding rod, which has thinness and depth. It's more or less a roundish object. So the average width, diameter of this, the average diameter of this thing would probably be no better to increase it beyond the width of the drip line of the tree. Of course, it would be quite a feat to bury this underneath the roots, or in and among. Actually, that was the quote, in and among the roots, because you've got to destroy some of the roots, half the roots, and then they'll grow back. So to some degree, on the side that they've been damaged. So then there's the question, how much damage to the roots can you get away with without killing off the tree to a sizable degree that it can't recover adequately? So maybe you don't get it as big as the drip line width of the tree. Maybe 2/3 or something, 1/3, I don't know. Something that, that has to be found out later on. So what was the third riddle again? Oh yeah, it's for a time lag. So the third riddle that we have to solve, we've already solved it using one of Tesla's patents, and that has to do with time lag. And you wouldn't think it had any value in a DC situation, but could very well be valuable. Now, this is all Nathan Stubblefield, so what does this have to do with Tesla's trimetal generator? If I can remember and go back to that. Okay, so in Tesla's trimetal generator we have now an iron winding mixed, so far a bifilar winding with iron and copper surrounding a aluminum core. Actually, no, we have a primary that's iron surrounding the aluminum core. Then we have a aluminum laminate surrounding that as our time lag, creating a loose coupling between the inner iron primary and the outer copper secondary. And then we have the copper secondary on top as a second winding. So we have a loose coupling between the two. We don't have a trigger coil because this is run by the machinations or the kinetic movement of the aluminum rod, which might not be a rod, it might be a barrel, a hollow barrel in reciprocating fashion, or a stack of aluminum discs, homopolar discs, with air spaces between them. In both cases run by compressed air, and so the reciprocating version is the AC version and the disc spinning version is the DC version. So is there room for a trigger coil? And what purpose would it serve and what would it be connected to? Well, there's no tree. An antenna. We never had an antenna in this device, stipulated by anyone. Is there something about Wardenclyffe we don't know about? There's a sidebar question which begs the question, is there an antenna involved? So What if Tesla simply took Nathan Stubblefield's patent and reinvented it by excluding the earth and by excluding a tree as the two elements, and then just finding analogous substitutes to regulate all the factors to improve efficiency instead of just leaving it to nature and, because they couldn't control the results with these earth batteries. Some days would be so powerful they'd have to disconnect the battery from the telegraph line because they had these batteries running at the telegraph office. And the telegraph line with the two offices, there are two batteries disconnected from each office, and they would still be running on juice from where? So Tesla may have simply reinvented Stubblefield's patent by converting it totally into a man-made, totally controlled situation, so that the Earth is no longer involved as a variable to its own discretion. Now man is in charge. So we have this earth battery that has to be set in motion by mechanical force, and now we have a third coil placed somewhere. So we're going to have to figure out how to where to put the trigger coil, and it's connected to a grounded aerial. With loose coupling among all three coils. Actually, now that I think of it, I never did think this thing through. So there are more questions, actually, that need to be answered. If the secondary is connected to load, what's the primary connected to? Whoops, kind of forgot about that. Maybe the primary is the trigger coil. Huh? What? Oh, iron, of course. And it's a long wavelength. That would go with the earth. So we choose a suitable wavelength a suitable length for the copper winding to match the characteristics of the load. If we know that the load is going to be a specific motor, in this case a U-boat, it's probably going to operate at a certain resonant frequency, so we make sure the secondary copper winding is a suitable length and number of turns and all of that business, mass of copper used to service the load, the inductive load that we're powering, the DC motor, let's say, or AC motor, whatever it happens to be. But the iron has to be connected. The iron winding has to be connected to something, and that is the trigger coil. See, this I don't understand. The 4 leads coming out of Nathan Stubblefield's earth battery. What's that? John Bedini seemed to know what they're for, and I don't. So I'm going to have to re-study that. What are those 4 leads for? Because I don't get it. Just going on my limited intelligence, which is extremely limited at the moment, the iron winding is the trigger coil, and it's connected to the earth through an aerial, a grounded aerial, which, in the case of a U-boat, is not hard. You've got the shell of the U-boat is your ground, and if you have an aerial isolated from the shell, from the hull, but extending out slightly from, what do they call it, the conning tower, shall we say, of the U-boat, then that serves as your antenna. But it's an aqueous antenna. It's connected to the ocean just as the hull of the ship is connected to the ocean as well. So it creates a sort of dipole in which the ground has precedence over the aerial in this case. In a tree, you could say the same thing in a tree because the roots are connected to the earth. And that, even though the root mass is less mass than the mass of the trunk and branches and leaves, the roots have greater significance. They dominate the tree because they're connected to the earth directly, while the upper portion above ground is impacted by the atmospheric influences, which being gases in the transferring medium, the ions of the air, it's less effective to communicate with the tree. So that actually is a bit of a loose coupling, while we have a strong coupling between the tree to the earth through the roots. So the hull of the ship now starts to matter, and maybe the riddle of the 200 pounds of iron is a double whammy of a riddle. So here, aha, I get to connect the iron winding to the hull of the ship, which is what I always wanted to do, is so that any iron mass of the device is connected to the iron mass of the hull to take advantage of that hull. So now I get to do it, but in a very structured manner, which I didn't get to do before because I couldn't imagine an iron winding. So now one end of the iron winding goes to the hull, and the other end goes to the aerial. They're isolated from each other, conductively speaking, to create a dipole situation of sorts, in which the aerial sticks out from the conning tower of the ship slightly. Not too much, of course, or else it would create too much drag. Or the U-boat drags a wire behind it. Isn't that the way those things work? Ships, when they want an underground aerial, they drag a very long tow line, which is the aerial. There you go. So you got a tow line towed behind the ship. That's your antenna. It's just a piece of wire, let's say, a long piece of wire. Could get snagged. Let's not drag this across the bottom, shall we? So maybe not too long, maybe 300 feet, So that's your aerial. And the hull is the ground of that aerial. And now you can add mass to the hull, and that, as well as add winding to the iron winding if you want to change the parameters of that frequency, that wavelength that the iron winding is supposed to be resonating with. Something to do with the oceans of the earth. So you find the resonant frequency of the oceans of the earth, electromagnetically speaking, and you create a suitable winding for the primary, geared to that, what is it, quarter wavelength or something? I don't know. What do I know? But yeah, I don't know. So the half wavelength idea that I had goes out the window. Whoopsie. I don't know what that's for. Oh, wait, no. That had to do with the core, the reciprocating. Oh, so if we have a slit down the the aluminum, slit down the length of the aluminum barrel, which is more like a rod, but it's hollow. And I don't know if the two ends are closed or not. So it may just be an aluminum pipe. A slit down the length to reduce eddy currents, I'm speculating. That allows for rotation. In fact, it may not even reciprocate, it may simply rotate. And now we don't need a stack of we don't need a Tesla turbine stack of homopolar disks, aluminum disks, unless we have a combination of both. How does that work? Oh, right. We have as many slits as it takes. In other words, the barrel is no longer a barrel. It's discs connected not by a central shaft, a central axle, but by supporting rods, shapes of aluminum struts at the periphery of the discs, going down the entire length of the stack to hold them all together. So it allows for air to circulate into the interior space between the discs and have and we can cut slots, teeth, to make teeth, so to speak, but slots in between the struts to make so that air can go between the discs. So now we have the same slot that that guy in Philadelphia had when he had a pipe and he had a slot or a break down the length of the pipe to, cue down eddy currents. Well, now we can have a reason to put in perforations on the discs to do the same thing. So we're breaking it up, basically. But it can both reciprocate and spin, which is a little weird. Or just spin and vibrate. Well, that's the same as what William Lyne said. It need only vibrate 1/16 of an inch. So if it spins and vibrates, the vibration is a precession, I bet. Not that that helps figure anything out, really. It's going to vibrate because it's not attached to anything. It's long. It's got a cushion of air all along its sides and interior. So it is spinning, but it is vibrating at the same time. Because there's no bearings connecting it to anything. It's just floating there on the interior of its whatever kind of tubing that it's sitting inside of. Let's say it's, something non-conductive, non-magnetic, non-magnetizable tubing of some kind. It is an aluminum piece. So maybe it should be aluminum, though, with a insulative interior to prevent our... Oh, no, wait. They have to be. That was the E.V. Gray motor. They learned to dispense with the Teflon chassis that was too expensive and difficult to deal with. And they went to an aluminum chassis with a Teflon coating on the inside to insulate it from the elements inside, and then they, of course, forced the air through to further prevent arcing. So so we can have an aluminum tube in which is this rotor, and the tube is your stator, and the interior of the tube is insulated with a dielectrical material, and the air flows through to prevent arcing. And then around the aluminum shaft, maybe we should call it a shaft, in which this other piece is rotating inside of that shaft, the stack of discs with their struts, and the cut slots on the exterior, the periphery of those discs, along with perforations along the surface of the disc. It may not be perforations, it might be spiral slots. Aren't they supposed to be spiral slots and not perforations? Or perforations in the shape of spiral to imply, if you connect the perforations, or it becomes obvious to the eye that it's a pattern of slots, of spiral slots, but actually fabricated as perforations. Structurally, that might be more sound. So the aluminum shaft that's rotating inside of, around that is wound the iron winding. Then we have a lamination of aluminum sheathing the primary iron winding, and then the secondary copper winding around the aluminum laminate. So we've got our connections, and we've got the configuration pretty much determined by need. What is the voltage step down that's going to be done? Well, part of the factor is how long was your iron winding in the first place? What was your wavelength in the first place? What was the Earth's frequency that you're trying to tune your device to in the first place? So your iron is your pickup coil with respect to the Earth. But that has to be translated into your resonant frequency that your inductive load is going to be operating off of, the secondary copper winding. So it has to be stepped down. So it's not only stepping down the voltage, but it's also changing the frequency, isn't it? How do you do that? Or is that done automatically? I think it's done automatically. So there's something about DC transformers AC transformers I don't understand. How do you maintain your 60 cycle hertz? So you have to do multiples of like halving the length of your primary if you're going to be halving in the direction of halving. In other words, it has to be clean. But if you don't do clean halvings, then what? Is that where you modify? Oh, wait a minute. Yeah, no, is that when you modify the operating frequency? Because we still have the time delay too that we've got. So we got three different things happening in the transformer. We're stepping down the voltage and upping the amperage. We're inducing a time delay factor, and we're changing the frequency. So those are the three design parameters that we have to allow for the characteristics of the earth frequency that we're trying to connect to, and the load frequency, the optimal load frequency to operate the inductive load, presuming there's an inductive load. In this case, the electro-U-Boat or whatever. Yeah, the optimal frequency to run your devices, the average or whatever it is. Or if it's a singular device, just a singular motor. I think I'll curtail this video right at this point because I can't imagine any further imaginings. But I am curious what the four connecting leads of the Nathan Stubblefield Earth battery go to, because it never did make sense to me, unless I did solve it and forgot about it, or figured it out, or learned from somebody else, but I forgot what the answer is. So I'm a little curious. So I made up my own solution, but I don't know if it has anything to do with Nathan Stubblefield. It's just my limited understanding, because we're not dealing with an AC transformer, so I don't know. And we're not dealing with the roots of an old oak tree either. Oh, good grief. Okay. That's going to gnaw away at me if I don't solve that riddle. Well, it's not a riddle. It's simply a lack of understanding on my part. Okay. Enough. Not to be dismissed is the Hutchison Effect, because John Bedini in his webpage says that it's electrostatics that's driving Nathan Stubblefield's Earth battery eventually, not at first. It overrides the weak, wimpy conventional interpretation of what an Earth battery is, namely just a battery, a galvanic battery. But it's wimpy. It puts out, like, what he said, a watt or something. It was really wimpy. But that's in the beginning, before it picks up speed, shall we say, as it's sitting there in the Earth, somehow. Well, picks up speed because the electrostatic force that builds up, that John Bedini is alluding to, is the electrostatic field of the Hutchison effect. So we've got an electromagnetic core to the operation of the device, just like Tesla's. But it builds up a field over a year's time buried among the roots of an old oak tree, and because of those other stipulations, the trigger coil is connected to the tree. So it still qualifies. The Nathan Stubblefield Earth battery still qualifies itself in satisfying the criteria of what the Hutchison effect of John Hutchison is defined as being. And that's where the overunity comes from, is the interaction of the radio waves interfering with each other in the midst of an electrostatic field. And so it has to be interpreted or analyzed with that as our parameters of analysis. Is it fulfilling the Hutchison effect? If not, then we've done something wrong either in its design or application or both. So we have to keep that paramount in mind. All the factors, do they satisfy or augment? Because that's what Evie Gray's motor runs off of. So it's a very basic idea, the Hutchison effect. Yet it has so many different ways of expressing itself. And here we've got Nathan Stubblefield in 1902. No. Was it 1902? Oh, shoot, I can't remember now. Yes, I believe John Bedini pegged it at or no, that was the patent from that guy that he was using as a reference. Well, whatever. This is, late 1800s, 1900, this is way, way back then, and they were harnessing the Hutchison effect. So we must keep that always in mind, not to exclude it at all, because it's a very significant principle that has to be applied, or else we don't get the over-unity. We just get this wimpy little thing that doesn't do much of anything worthwhile, certainly not over-unity at all.